All right, thanks everybody for joining us. My name is Kevin Sloan. I'm the director of the University Rover Challenge, and I'm extremely excited to welcome Doug Milburn from one of our longtime sponsors, ProtoCase and ProtoSpace Mfg. Doug, thank you so much for taking a little bit of time to talk with me today.
Right on, Kevin. Thanks for being here. Thanks for letting us be part of this for so many years. It's just been a great ride. Absolutely love being part of this.
Yeah, it goes back to 2015, I think was the first year you all came on board, and really, ProtoCase and ProtoSpace have become synonymous with URC at this point. It's been incredible working with you all. So we'll get into a little bit about what you all do, details of the company, and a lot of the exciting work that you all are doing for the broader industry, not just teams. But we'll also, a little bit later, we'll get into the details of the sponsorship. So for any of the teams listening, it's important to note with the ProtoCase and ProtoSpace Mfg sponsorship, you have an opportunity to get free parts and products produced, and those actually give you an additional extension to your budget cap. So you have an opportunity to get professionally built parts that don't count against your primary budget cap. So we'll get into the details of that a little bit later. But first, Doug, for some of the new teams or teams that haven't had a chance to work with you all yet, at ProtoSpace Mfg, what do you all do?
Okay, so ProtoCase and ProtoSpace Mfg, we make machine parts, sheet metal parts, electronic enclosures is an important part of what we do, and these are things. I mean, there's been machine shops, internal shops, university shops. I've done this work forever, and so we make the same products they make, but we just do it in a dramatically different way, and in a way that's very specifically designed for people who innovate. If I could use that word.
No, it's great. And having seen a lot of the work that you all do, incredibly high-end work, and setting the companies up that we have, it's a very unique model. It's not something you come across very often. So I am curious. With URC teams, we think about everything in terms of their project life cycle. And creating a company, there's a project life cycle that goes into creating a company. So I'm actually curious about the origin story for the companies, since you were one of the co-founders. What led you to the creation of the company, and how did you go about setting everything in motion?
Yeah, look, let me go back to myself. I grew up loving science and making things, and computers came around, and our access to computers came around, and I'm just, let me say the word geek proudly, just absolutely love that. Went off to university, died, went to heaven, took a couple of physics degrees, then an engineering degree, and experimental hands-on. I would love, machining things, making things, putting stepper motors, servo motors on them, programming computers, and moving stuff. So my business partner, we've been buddies for a long, long time. Actually played rec hockey together. And met in the dressing room after and chatting. And he's, similar. And, we're just talking about, when you want to make, design things and build things, and you need parts. A whole bunch of things you need, but parts are one of it. And it just really irritated to us. We were early in our working careers, and I was around an innovation-based company. So was he. He worked in the world of marine navigation electronics, developer and manufacturer of, work in materials research and building manufacturing equipment. And just these variable delays that you get when you're doing a project, and you come up with a design, and you're so excited about it. And you can envision it work, and you can taste it, and you just want to go put this thing together. These ideas you had, some electronics taking shape. Now I need metal things, motor mounts or enclosures or whatever else. And you go to this industry that is, it's I call it job shops, machine shops, sheet metal shops. Be an external, internal. They're the people that made those parts. And we realized that's the same business model that when James Watt was building steam engines in the early industrial revolution, he was going through the same thing. Those people imagine their steam engine, and they'd be doing their designs on probably on parchment, rolling them up, putting them in a satchel, riding on a horse over to the job shop. Hey, can you make this? I can't. Can you change that? You change that back and forth, back and forth. Hey, here's your quote. Okay, how long will it take to make that? Well, let me see how busy the shop is. Can't even answer that, right? And we look at that, and you get waiting weeks or sometimes months to get parts. And we said there's got to be a better way. And specifically, people like us, low volume, often one-off, making first of, and whatever. And then we said, so we set about back in around 2000, creating a better way and created something called high velocity mass custom manufacturing, the successor to the job shop for scientists and engineers.
It's definitely a problem that resonates for any of us that have gone through product and project development, where it can be a critical bottleneck. And so, it's something we talk a lot with the teams about early in the design cycle, coming up with a good, rigorous project management plan. For teams, one of the first milestones that you're going to have for our listeners out there is you have your preliminary design review report due in early December. And one of the biggest focuses of that is developing a project management plan and understanding how all of those critical tasks lay out on a schedule. And certainly the actual manufacturing phase is a critical phase of it. But as students, we have different levels of expertise with manufacturing. And when I say we, of course, mean the students. I myself am far more removed from my student days. But as students, varying levels of expertise with manufacturing. And so being able to accurately predict schedules for that is incredibly difficult. But then you actually need all those things to get produced and come together before you can move on to integration and testing. And of course, teams, you need to be well into your testing stages if you want to be successful for the system acceptance review in March. And so that's a really tight timeline on there. So, with some of that in mind, Doug, how can you help teams accelerate through that phase there?
A great topic and dear to my heart. And let me just dive in and say the challenge that the teams are facing is the same challenge that I faced in my research project, my master's, my PhD research projects, my postdoc research, and then when I started my first company. And it's you got a group of smart people and passionate people getting together. They got a vision of where they want to get to. You got to do that. So you need formal project planning. The Gantt chart, I think, is mission critical, and I still believe it's mission critical. But I've learned over my 30-some year career, it's necessary but not sufficient. And I also, people go and research these teams. Most research teams get bogged down and end up behind schedule. Right? And I go, how come we can't do this? And starting the company, and our company culture, we don't use a hammer. We really try to create a collegial kind of environment inside the companies. And at one point I said, can you guys just get your Gantt chart and work harder? Put a Gantt chart. You guys don't work hard enough. And so in a 25-year quest to really get to that, how do you put a team together? And how you make stuff happen, whether it's, a company like a private space company, or it's whether it's a student project, or whether it's a single research project somebody's in grad school. It's all the same thing, and take your Gantt chart, put that together. And Gantt chart project management is taught. One of the classic examples, they'd say, hey, a company building a tract of houses in a subdivision. And you got to figure out the excavation first, then concrete, then you get dependencies. They got all these rules, and every team should get to know that stuff. But I'm going, why doesn't it work all that well in research? Research works worse without it, but it doesn't work well on its own. The answer is uncertainties. Because if I'm building a subdivision, my company's been doing that for 30 years. It's all pretty predictable. You might get a snowstorm or a flood or something that'll throw you off, but you really get it. It all makes sense. In research, here's the problem. The best laid plans, never really happen because reality comes and whacks you. You have a great idea, and you try something. I don't know, you're going to develop a new drive system and gearing, and this is how you're going to drive your wheels and your rovers. And it's clear to you in your head. And then you go off and you try it. You know, you build things, all that enthusiasm and all that energy that you need to drive your projects forward. And then you turn the switch on, and oops, something doesn't work. There's always failure in it.
Never fails.
Yeah. And Kevin, if you're not into embracing failure and loving it and loving that challenge of saying why, see smoke come out of the motor, or whatever happened. We know those things. Everybody knows those. The students who are early in their sort of science engineering careers, they have a taste of it. It's those uncertainties. And so here's what we come up with. We have something called Project DNA. It's one thing we teach out. And this is the culmination of everything I've learned in my career internally, my research, all the projects we do in here. We have about 35 people in our research development group of the company now, watching them do projects, and then living vicariously through our 20,000 plus customers, including the very best of the aerospace industry, and watch them struggle with it, watch those who win, watch those who don't. So number one is clarity of goals and what you want to achieve and how you get there. Not be loosey-goosey about it. Write that stuff down. Think about it, discuss it, be really, really clear. The old expression, if you don't know where you're going, you're less likely to get there. So getting that, what's success, what's failure? What's your piece? So each piece of these things, Gantt chart, have those goals down there. Realize, and then that's number one. Number two is embracing, actually, sorry, I'm skipping one. We have something else we call who list. Who's the people in your team? Who's the professors you have? Who's everybody you know? Somebody's squirreling off and going, hey, I'll take that and solve it myself. It works way better if you open up in your team, trust each other, enjoy each other, love the technical conversations.
Absolutely.
Get input. Somebody will tap you in the shoulder and say, hey, have you thought about that? Oh, I didn't. My God, I do that. I'm all these years into my PhD and my subject matter and deep experience. And I go, the first thing I do when I'm tackling something new is I talk to people. And I learn from them. That gives you a foot up. Number two, embrace uncertainty. Realize that the rest of your Gantt chart ain't going to happen the way it is now unless you have some kind of all-powerful seeing ability, because nothing turns out exactly like you think it is. So that shapes the other thing. Successful teams realize that. So they say, I got to resolve my uncertainties. Figure out what your uncertainties is, figure out what you're going to resolve, and your project plan, your order of execution should be to resolve your uncertainties. If you're going to do a very, very new drive system, okay, and your rover, what if that doesn't work? What else is that going to affect? So should I address that first before building the suspension, right? Think about that. Think about where your uncertainty points are. And now when you got uncertainty points, your job is to resolve them. How do you resolve them? Well, you build something, you try it. It's called experimental development. It's the core of what you do. And you jump in there, and that happens in threads. We call it threads. It's a work thread. Okay, I'm starting this. Let me get out. Let me do my CAD design, make my parts, buy my motors, get everything moving, and then turn on and test it. But I can't design my suspension, or if I do design my suspension, I'm taking a big management risk, and I may have to reverse and redo all that work. So the faster I get my answer, the better. So now your sense of urgency comes in and you get speed. So, and again, I'll put my ProtoSpace plug in, but in general, we fall under this. So we have a rule in there. It says ruthlessly eliminate latencies. What's a latency? It's a delay, right? In those work threads, your people, your team, the particular person who owns that thread, if they ruthlessly eliminate latencies. Well, what's a latency? Well, I got to wait to talk to somebody. Well, call them up now. Don't text and wait for them to get back. I need to order parts. How long is that going to be? Oh, that's going to be 4 weeks. Find another supplier or find an alternate part. If I need to build, and I'm talking off the shelf parts, I need parts made for me. Oh, well, put it into my university machine shop's going to do it for me. How long is that going to take? 3 weeks. That's a latency. That's killer. Okay, let me talk about that in latencies. So if you don't eliminate latencies, here's what happens. Groups developing something. They start a thread, they start working on all their enthusiasm, they put their order in for parts to 6 weeks. Good, okay, we'll drop the 6 weeks, we'll work on something else. They start a new thread. The new thread stops when it hits a latency. They work on something else. And then they move along. And this pattern happens over and over and over, everywhere at the professional level, especially. What happens in rover teams? And it's like, and here's the killer. Nothing gets finished. The answers, the uncertainties don't come. And your enthusiasm for your thread drifts. Why? Because you have enthusiasm for another thread. And everything gets muddled. And you're going, oh, they had this Gantt chart and everything was going to be great. Well, your latencies and thread switching kill you. You can get that. I'm giving there's a lot of wisdom. There's 20,000 companies, observing 20,000 companies worth, and us working on this for years and years and years. It just comes down to that. Happens in threads, clearing what you're doing, clearing your threads, clearing how you put them together, and ruthlessly eliminate those latencies. And you will thrive. That's why SpaceX has thrived. If you watch what they do, they work that. I don't know if they use the words. I haven't heard those words in there, but it's exactly what they do. And yeah, that's it. Oh, and it becomes way more fun for the people doing it.
Oh, yes.
Finish stuff, right? So that's
no, it's it's incredible guidance and certainly a lot of wisdom in there. Very very hard earned wisdom, which usually wisdom comes on the tails of battle scars. But I spend my professional career. I work in project management for research, and everything you talk about there just resonates so clearly. And it's a lot of themes that we see consistently. You talk first and foremost about the Gantt chart and coming up with a schedule, and that's it's a skill that you can always work at and get better at. But the most important thing that routinely, and it's not just with student-based teams, this is something that professionals struggle with as well. A schedule gets built, and it's usually built as a deliverable requirement, and that schedule gets put on the shelf and then ignored, and then everybody goes back to just kind of fighting the fire that's closest to you at any given moment. But the important thing with a schedule isn't that you adhere rigorously to the schedule, because especially as you talk about in research, there's so much uncertainty, and you're going to learn things through testing early so that you can get that learning opportunity in place as quickly as possible. And that learning iterative feedback loop in there is so critical. But then taking that new information and continuously refining your schedule and your Gantt chart so that your Gantt chart is an event-driven schedule. And so we know what the end state is. And so for teams, there's a couple of big milestones that you have to think about. So when the system acceptance review deadline is. And so that is something where you need to have your best effort ready before that deadline so that you can show the judges what you're capable of. And then for the teams that make that down selection and qualify for the finals, you know what the rules are, you know what the missions are, and you know what the dates are. So we give you all that information up front. So again, as an event-driven schedule, as you were learning and finding that something took longer, something moved a little quicker, you ran into an unexpected challenge. It happens to every team, but adjust your schedule and make sure that you understand what the path to closure is. And that gets back to, as you talk about, Doug, the clarity of goals. And then, with driving latency, latency is something that increases in severity the closer you get to a deadline. And, ask any team that's been out there, and certainly the week before competition, the week before the system acceptance review, and then, even in the middle of competition, latency, you care about minutes at that point. You care about seconds because you're scrambling to be able to put every additional ounce of effort into it you can. But I think what's natural for all of us as people in general is when you're a couple months away from a deadline, losing one day or 1 week doesn't feel all that bad because I can make up that day tomorrow. But when you start getting to that end game and that schedule starts to compress on you, those days that you lost, those weeks that you lost because you were waiting for a latency, something that was being held up to come through, those are minutes, hours, and days that you desperately wish you had back, and you don't know it until it's too late.
Can I let me throw in the word deadline? And all the people around the company here, now our North Carolina location, are kind of getting it too. I'm a hater of deadlines, and when I watch projects done well, it works on start lines. And again, I'm just going to put different words and just a slightly different angle on exactly what you said, and in hard agreement with what you said. That problem at the start, it's going to be a week. We'll blow it off. We'll make it up. No, you never make it up. You never get the time back, right? And when we watch the things that we do successfully in this organization, operational, a scientist passes us a job to make some complex metal for them that they require. We take that in. We'll take that, and for the time we agree on a drawing on it, we will build it fully finished. Could have powder coat, printing, labeling, chem film, aluminum coating on it, all the fabrication, welding, everything else. We do that in 2 to 3 days. We do 40,000 tasks a week now, and we get that out on time to these people who are doing these projects. And if we did it in deadlines, I'll say to people, it works on start lines. It gets broken up into tasks, and somebody starts a task, and there is a timeline of how long the task should take. And I go, if I took those 40,000 tasks and threw them over into our operations or operational engineering and plant and said, here guys, here they are, here's the deadlines. They'd hang themselves, noose around their neck, and they'd hang themselves, and we'd be late. We do it in start lines. And if research projects were done, and we have morphed our research groups inside product development, process research, and things like that. And because the deadline thing, I go and I'll just have a little fun. I criticize my, how much money I spent in my university education, my 13 years from start to end, till I come out with PhD, and it's all deadline driven. I teach you deadlines, and deadlines exist, and you need to do them. But working back in project management and getting your start lines, because you can't, you can work your butt off, but you don't have control over how the project goes. And it's like, what you got to do, it's about starting a task. When should you finish a thread in your research project? Well, you can do a Gantt chart and you create artificial deadlines, but they don't mean anything to people. And again, they don't have immediate consequences. They don't mean anything to people. It's about start lines and then executing that. We call it, there's a concept, this incredibly useful concept, is velocity. If you did something, and if your mental resources was one person, and you did something that took 40 hours. If you accomplish that in 1 week, one nominal work week, you're at 100% velocity. Again, it's fuzzy, it's people stuff, so the measurements are fuzzy, but you create the measurements to work for you, just like every other measurement in Earth, right? And you figure out what you measure to make it work for you. So your velocity, your thread velocity, is the amount of hours you worked on it divided by your resource hours. And that were available during that period. And what we find in that velocity thing, again, what kills velocity? Latencies.
Absolutely.
And note, I'm not talking about working hard or fast. Rushing never helps. Do not ever rush. It's about steady and it's about methodical. That gets you there fastest. But get rid of the damn delays. Like, get to work. Don't have that extra cup of coffee and go blah, 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 blah. And it's like, dive in. I'm actually doing a project on my boat right now, putting Starlink on my sailboat right now. And it's like I get there and I start the task and I work on it through to the end and I focus on it, right? And those threads, and in research where there's uncertainty, you start, move that thread through, ruthlessly eliminate latency to the degree you can and get to the end of it, right? Because you can put up a deadline, and deadlines created. I said at university, get their term papers and projects and everything else. We all have done it. Everybody in university has done it. You get there, and this is due in November, and September we start that. Yeah, I'm going to be disciplined. I'm going to work, and you don't. I don't know, campus pub or the library, hanging around talking to people, blah 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 blah, and having fun, which you got to have in life. But it's like, I went to university. I was deadline driven. Everything pushed up to the back, but I got capability to do these chunks of work and just focus on it when I sit down and do that. And I go,
Yep.
and I think about it now, and I go, well, what would have happened if I took that same power that I, gift and ability to just focus and, write a term paper, even bored the crap out of me, and just, what if I started it and just got her done? I would come into exam time and, end the term, and I would just like drifted through it, and the pressure levels would have been off and everything else. But we use deadline to put pressure and motivate us. But deadlines, I watch organizations try to function, and like a deadline, having a gun to your head at the end of the day is the negative motivation. It's a stick. It's not a carrot. But if you can get your group, to get your start lines, work them out from where you got to do your start lines. How long does the task take? And then it's project management, Kevin, right? So it's what I'm talking about. It's Gantt charting and that kind of stuff. But you do that, and you say, the importance of my start line, and then measure your velocity. If organizations, including our own, I see a close up, I feel it. It's stunning. Organizations that do things at velocity, you're never going to achieve, you're rarely going to achieve 100% velocity. And you focus on it. What am I doing now? What's the most important thing for me to do now? Good. Do that. Take it through to conclusion. And being finishers, like everybody talks about all these pieces, but velocity brings it together. And you think of your threads in your team, you think about when you started, and if you start it and you push as close to 100% velocity as you can, and then, when you're waiting for something, when that project comes back in, there's got to be one priority project that you work at maximum velocity. Yeah, you're going to have latencies and you're going to work on other stuff, but use that as a little get ahead of the other stuff. If you do that, you're going to succeed in spades. And if you learn how to do this, your rover project's going to work better, and you're going to get out in the workplace and you're going to kick ass. And you're going to, if you can bring this into your groups you work in the workplace, they're going to kick ass. That's the groups that we sell to that are the winners. That's what they do.
Absolutely. Yeah. And, when we see so many of the URC students graduate and move on to careers, so many of them are moving on to these incredibly exciting companies, getting immersed in R&D projects at the beginning. And it's because they've got that project management DNA and having gone through URC. And so, yeah, it's such an incredible skill. You talk about velocity. If you can't measure, you can't improve it. And so, there's different ways that you can measure velocity. And, the important thing for teams is figure out what works for you. But even if you're not doing a rigorous calculation of your team's velocity, even as simple as just making sure that you're actually using and updating your schedule in real time. And if you commit to keeping that schedule refresh and taking a clean look at it once a week to update on where current progress is, I think it jumps out very quickly that, Doug, you talk about the start line, and it's such a minor shift in wording, but it's a paradigm shift when you really embrace it, and the importance of making sure that you're able to start the tasks at the right time. And that's really what drives you to getting away from latency. And so, with that, I think it's probably a great time to talk about the ProtoSpace Mfg sponsorship for teams. So for all the teams out there, if you are looking to work with ProtoSpace Mfg, have them develop custom parts to your design drawings and specifications. The way the sponsorship works is you essentially have a $2,000 credit with ProtoSpace Mfg. You can use that $2,000, and then if you exceed that $2,000, you get a 50% credit for everything above that. Now, where it really gets exciting, we have with the URC rules, of course, by this point, everybody's read through the URC rules, and you know that you are limited to fielding $24,000 worth of value on your rover. Between your rover, your control system, your drone, there's a $24,000 budget cap. That's not your team's overall working budget limit. Anything that goes towards prototypes, that doesn't count towards the limit. But the fielded rover in full system there, it has that tight limit of $24,000. Well, if you take advantage of that first $2,000 from ProtoSpace Mfg, that does not count against your budget limit. So if you have $2,000 worth of parts from ProtoSpace Mfg, you pay $0, and you now have the ability to field $26,000 worth of value out in the field. So that's an incredible opportunity there. If you go beyond that $2,000, you get that cost savings there. That does start to count against your budget limit there. But for $1,000, you can get $4,000 worth of professionally produced components, subsystems, and that there's the cost savings there. But then what have we spent this conversation talking about? Latency. Latency disappears for some of your critical components and things where you might need a part built to manufacturing tolerances that is students, your skills just may not be there, or the university machine shop may not be able to do it to those tolerances on the timelines you need. So yeah, incredible opportunity to take advantage of that sponsorship. Thanks to ProtoSpace Mfg and the ProtoCase team, who like I said at the top, have been really so instrumentally intertwined with URC. Really part of the fabric of what makes this an exciting competition. So, we're always appreciative of the support you've given to URC and all of the teams. And this has been a tremendously exciting conversation. When you get a couple of veteran project managers in a room, especially working in the R&D industry, it's sometimes sharing war stories. It becomes like therapy in a way. But we see similar themes, and it's things that don't just apply to student teams, but they're lessons to learn that impact industry. And from our vantage points, for me having been able to watch a large number of student teams over the years, and certainly on the professional side, getting to watch a lot of teams. But then Doug, from your position, you talk about the extraordinary number of organizations and projects that you have been able to touch and affect, and so you're getting insight into all of those development life cycles there. So that the wealth of expertise that you've been able to bring to this conversation is extraordinary. So I want to thank you for your time. It's been just an incredible talk.
Oh, thank you very much, Kevin. As I said, this is just so close to my heart. I wish I had student projects. I never really got the opportunity to do student projects like that in my undergrad years. By the time I got to grad school, and sorry, I did. We had strong undergraduate thesis project, and I had a couple of summer research fellowships. So I got to do hands-on stuff from after my second year in undergrad, but I never got to work on a team like that. And I'm just jealous of all the people that get to do that, and living vicariously by through our team who's out there. I haven't been there the last couple of years. I expect to get out this year. And Utah, for those that haven't been out to the site there, the Desert Research Station, Utah is a beautiful state. Every corner you drive around, it's a completely different landscape. It's stunningly beautiful. And the research station there, it's for me, it's an East Coaster. It's a surreal experience to catch the Southwest and everything else. So anyway, I'm rambling on about it. Just such a great experience, and thank you so much for letting us be part of it.
Oh, absolutely, and we're excited to welcome the team back out in the field, and we'll definitely see you out in Utah. And before we go, I almost forgot to point out, and I'm sure some folks caught it, but it certainly makes me laugh a little bit and have to appreciate that this incredible Canadian company was born at Rec Ice Hockey League. Couldn't be more quintessentially Canadian. So
I love it.
Yeah, for all the international teams out there, we all have our own regional sports that everybody's involved in. So it's a great story, and again, great conversation. Thank you so much, Doug.
Awesome. Thank you, Kevin.
All right. And teams, we look forward to bringing you more content in the near future. Have a great day and good luck with all your projects.